It is a fact that every single integer can be expressed as a product of prime numbers. We're going to look at two techniques for doing this. Let's start by considering the number 90. We can use a technique called a factor ladder. We write down 90. 90 is even since it ends in a 0. If we divide 90 by 2, we get 45. 45 is not even. But if we add the digits, 4 plus 5 is 9. So 45 will divide by 3. Dividing 45 by 3 gives us 15. Once again, 15 will divide by 3. If we divide 15 by 3, we get 5. 5 divides by 5, giving us 1. We stop the process when we get to 1. We can now write that 90 is equal to 2 times 3 times 3 times 5, just reading from the left-hand side of the ladder. Let's consider 108. 108 is even, so we'll divide by 2. 108 divided by 2 is 54. This is also even, so we'll divide by 2. 54 divided by 2 is 27. 27 is not even, but 2 plus 7 is 9, so this number divides by 3. 27 divided by 3 is 9. 9 also divides by 3, giving 3. And 3 divides by 3, giving 1. So 108 is equal to 2 times 2 times 3 times 3 times 3. Another method for doing this is called the factor tree. We take 90 and just look for two numbers that multiply to give us 90. For example, we might come up with 3 times 30. 3 can't split further because it's prime, but 30 can. 30 can split to 3 times 10. 10 can then split into 2 times 5. So we end up with primes at the end of the tree. Note they're the same primes that we have here. Doing the same for 108, we might spot that 108 is 4 times 27. 4 can split into 2 times 2. 27 can split into 3 times 9. And 9 can split into 3 times 3. Note at the end of the tree we have primes, and that they are the same primes that we found using the ladder. Just going to pause in this discussion briefly to discuss indices. Here we're just going to look quickly at positive indices, which are whole numbers. As you progress through GCSE, you'll find that there are indices other than positive whole numbers, but we don't need to discuss these here. 2 times 2 can be written as 2 squared, or 2 to the power 2. The small 2 above here is known as a power or as an index. 2 times 2 times 2 is 2 cubed, 2 to the power 3. If we had 5 2's in a row, 2 times 2 times 2 times 2 times 2, this could be written as 2 to the power 5. If we consider this chain here, we have a 2, which we could write as 2 to the 1, but we tend not to write the 1. We then have 3 3's in a row, so these can be written as 3 to the power 3, and then 2 5's can be written as 5 to the power 2. So let's apply this to the expansions we found before. We have a single 2, 2 3's, so we can write that as 3 squared, and a single 5. Looking at this one, we have 2 2's in a row, multiplied by 3 3's in a row.